Happy Women's History Month. I am your host, Mariah Gagliardi, Senior Solutions Architect at AWS. And today we have a very special episode as part of Women's History Month, where we get to celebrate at this time the social, the economic, and the cultural achievement of women and those that identify as women and non-binary. We have International Women's Day right around the corner on March 8th. And as part of AWS She Builds Tech Skills in North America, we wanted to highlight the stories of our own She Builders that build amazing projects leveraging the latest AWS technology. These projects were part of AWS reInvent 2023 Builders Fair. For those that are not familiar with the Builders Fair, at the Builders Fair, you get to interact directly with AWS projects and their builders. It's a very similar experience to that you get when you go to a science fair. And today we will take you around the expo floor to meet some of our own She Builders. They will walk you through their projects, the architectures, the AWS services that they leverage. There are 7 different She Builders and projects and demos that you will get to experience today. We will start off with Magic Mirror, where you will learn how to use generative AI to build a mirror that creates a new you. And then we will stop by the Robo Chef booth, where you will learn how they leverage AI and ML services to provide recipe suggestions with items that you already have in your own fridge. We will stop by also the DuckDuck Go booth, where you get to play with ducks and also start scoring points as you go fishing. Jumping into gardening, you will hear from Anna on how Plantly can help you both remote monitor and water your plants. And for those that are into or excited about chaos engineering, stay tuned for Chaos Kitty. They will do a demo that you will not want to miss if you're into security and interested in security and AWS. And since AWS reInvent 2023 took place in Las Vegas, we will stop by Poker Seer booth. And here you will learn about how you can leverage AWS technology to build your own poker companion. And for those that are interested or passionate about Legos, we also have a demo for you. If you stay tuned at the end, you'll hear from Big's Maestro demo, where you will learn on how they used AWS services to identify different Lego parts. So let's jump into the expo floor and hear directly from our She Builders.
Hi, my name is Germaine, and I'm a cloud architect with the APJ Professional Services team. So today we are at reInvent, and let me take you on a tour on our product, which is called Magic Mirror. So Magic Mirror is an immersive mirror display, and it is integrated with a few components of Alexa, as well as Raspberry Pi. So this is the architecture diagram. So without further ado, let me dive into a demonstration of how our product works. Alexa, run my Magic Mirror.
Welcome to the Magic Mirror.
Alexa, draw me as a cat, closely resembling me.
Look into the camera and smile. Your image will appear shortly.
So the Magic Mirror would take in an input image of what you see in the mirror, and it runs through a series of services. So what it does under the hood is the image will pass into the Amazon Bedrock API, which runs an image-to-image inference, and given the user prompt that you give to Alexa in the beginning, it will generate the image back to you on the mirror display. And that is how Magic Mirror works.
I'm a solutions architect based in Singapore. So today I'm at reInvent 2023 and our Builders Fair booth. So our booth is called Robo Chef, and what Robo Chef does with the idea behind it is we want to reduce food wastage and from the sustainability perspective. So how it works is just 3 simple steps. The first one is we'll have this app to take a photo and scan for ingredients, and then from there we'll generate ingredients based on the large language models through generative AI to give you some creative recipes. So let's imagine today I'm at home having my fridge. So when I open my fridge and I ran out of ideas what to cook and I didn't know what's available in my fridge, so I'll open my app and Robo Chef will do the work for me. So from here, we can take a quick photo and we can use the photo and upload for it to detect the ingredients. So behind the scene, we actually do have some AWS services powering it, and it includes recognition, which does the detection of the ingredients. And as you can see here, the detection is done, and we can validate that there's a bell pepper here, an egg, containers where it can read up the text, and also carrots and lemon. So let's see what our Robo Chef suggests the recipes for us, and we can generate the recipes, and boom, there you go. We can have a few recipes that is generated by few selected large language models, including Claude, Jurassic, and also other language models that we have tried. And refreshing it might give you more ideas, and also including what we have in the recipes is we generate out the recipe image with stable diffusion, and all these ingredients that's detected just now, sausage, bell pepper, and butter and others, and instructions generated by the large language models. So for some recipes, we might have some missing ingredients. So for example, these are the available ingredients that we have detected and the missing ones, which you might need to get from the store. So that's all for the demo, and if you are interested, do check out our solutions from here, and hope you enjoyed the demo. Thank you.
So hi, my name is Anisha. I'm a solutions architect at AWS. I work with AWS Canada, and I'm here for a little over 4 years now. And what I do is that I help customers when they have to move their migration from on-prem to AWS cloud. I also provide guidance when they have to create new solution in AWS or just normal maintaining stuff. So what we have here is a DuckDuck Go. What is it? It's inspired from a Carnival 2% game. And the logic here is that you have to gather as many ducks as possible to win the game. So how it is built? It is built on totally on AWS solution. And when we start the game, we have to press a physical start button, and it sends a message to Raspberry Pi, which is going to spin this platform. And when it spins, you have to just, it's all magnetic. We have ducks, and there we have magnets placed on them. So you just gather this stick, and it's magnetic. You can just get it, hook it up, and place it on the scoring pad. And when it's on the scoring pad, our near real-time streaming is going to start, and it's going to send signal to recognition, which is our computer vision algorithm. And what it does is going to detect the number of ducks and the colors, and it's going to calculate the scores automatically. To make it more interesting, we also have a duck that is going to score a double than rest of the ducks. So all of the ducks have 100 scores, but one color will have 200, and you will display that on the screen. And if you get that, and you are going to get double the scores. We also have digital print implemented, and it's a 3D representation of this platform and the scoring pad. So we are going to do a demo for DuckDuck Go. As you see that it has already entered our names, and now we are going to press the start game, and the platform will start spinning. Now you can see if you get the green duck, it's going to go to double the points. Harder than it looks. Recognition is going to recognize that what color of ducks and how many ducks we have gathered on the scoring pad, and it's going to calculate the score automatically
solutions architect for Iberia, for SMB. And here's my project for 2023 reInvent Builders Fair. So what we build here is Plantly. Plantly is an application that allows remote monitoring of assets that are scattered around the world. Here we have plants, domestic plants, but you could think about anything, any kind of plant, like industrial plant, manufacturing plants, or crop fields, or trains, healthcare devices, anything that you need to monitor, and it's in different places of the world. In this case, we have 3 plants, one in Munich, one in Madrid, and one in Las Vegas. And what we are doing is sensing, like with sensors, we are monitoring these plants. We have here the AWS IOT, which is a device that's a partnership between Stack and AWS that is connected to a temperature and humidity sensor and a water pump that has a soil moisture sensor integrated. So what we are doing is we are sending this data from these 3 plants to AWS. So it all comes through the IoT core service, and we are using different IoT services of AWS. So what we are doing is, on one side, we are storing the data on a DynamoDB, so we can consume it later, for example, for the web app. And we are also sending this data to IoT Sideways. IoT Sideways is a service that's thought for manufacturing purposes, especially, where it allows to collect, organize, and analyze data. So when you have like a big scale of manufacturing plants, for example, and machines, and each machine has different sensors, it's easy to monitor and to centralize the information. So here, this is how we embedded the IoT Sidewise metrics on a website. And what can we also do? Like, what happens, for example, if my plant is thirsty and I need to water it? So what we can do also is interact with it. So we can interact with the different, like we can ask through IoT services to water the plant, either through the website, through this little button, or through a chatbot. But the coolest part is that you can also interact with the plant with Alexa. And we did this thinking about not only that it's nice when I'm on vacation to water my plants remotely, but also about these use cases where we have workers that work on a lab, or that work like with gloves, and it's not easy always to handle device, like to be with screens and so on, that you can use Alexa, for example, to ask about data about your plants or to water it. So let's see. So Alexa, open water my plant.
Sure, I would love to water your plant. For which location?
Las Vegas.
Your plant in Las Vegas was already watered today, 4 minutes ago. Are you sure you want to water your plant?
Yes. And we see there the pump.
Successfully watered plant.
Alexa,
in
stop.
Las.
Alexa will keep on giving us the new data from the plant and the new moisture. We are not seeing how it waters the plant because here at the Builders Fair we are doing this over and over again, and we don't want to drown the plant. That's why we are using a glass of water. And yes, this is our project. Remember, this is just an example of how we can use remote sensors to monitor our plants, but you can use this in anything that you want to monitor. Thank you.
Hi everyone, my name is Suja and I'm an Associate Solutions Architect working with the ASEAN emerging markets, and I'm based in Singapore. But here I am at reInvent 2023 with my team, and we are demonstrating Chaos Kitty. So what exactly is Chaos Kitty? It actually focuses on the importance of doing chaos engineering within your systems to firstly look at testing resiliency within your architecture and infrastructure, and secondly, it also emphasizes the importance of standard protocols or SOPs to respond to security incidents. Okay, so what we have here is actually a visual setup. It's a very flashy setup, but a visual setup of a 3-tier web application. So these common web architectures are actually very popular among many different customers running all sorts of services. So we have our Lego blocks over here, and we also have very flashy light bulbs. So all these light bulbs actually represent a specific resource or a specific feature that you can find within the AWS console. So for example, we have a little red box over here that actually represents a security group. And over here, this light bulb, when it's green, it will show that the security features within this security group is actually compliant. However, when it does turn red, what it means is that there is a misconfiguration in the service. So what we're going to do today is to actually try out misconfiguring and injecting faults into our system. And what we're going to do is that we have buttons over here that triggers a lambda function in the background to inject a fault into the system. Meaning we're going to go in and misconfigure something. So we are going to inject just one fault. So when I press the button here, what it does is that it actually sends and communicates to the AWS cloud to run the lambda function and misconfigure something in my environment. So right now you can see that something just went wrong. So something turned.
Your S3 web app static files bucket is open to the world.
Okay, so Alexa has done a very good job in helping us.
Your EC2 security group
Yes,
is
we
now
are
defined.
injecting multiple faults in this case. So Alexa has done a good job in identifying that, okay, we have an S3 bucket that just, something is misconfigured there. And we also have a security group for our EC2 instance that is misconfigured. So your role as a participant, and very fun thing that you can do at reInvent, is to come over to our booth and you have to beat the timing and fix the problems in the console. So what we're going to do right now is to actually go into the console. Okay, and we're going to identify the first potential area, which is a very cute and a little bit flimsy S3 bucket. So we're going to head to the console and search for S3. Okay, so when you're looking at this, you're going to be wondering, hey, I don't exactly know what happened and what caused this to turn from blue to red. So there are two ways that you can go about looking for certain error logging and things like that. So the first one is actually just looking at the visual, very flashy Lego set that we have and identifying the resource that has been misconfigured. However, when you want more detailed logs, observability is a huge part of AWS. So what we have on the bottom right here is actually the CloudWatch logs. So CloudWatch essentially monitors all the different resources and activities that's happening within your console or within your infrastructure. So everything that happens on the AWS console here is actually an API call. So within your CloudWatch logs, you can actually scroll down to search activities that has happened with the S3 bucket. So if we take a look at S3 over here, we have an S3 bucket called web static files over here. And what happened is that the event that happened was that it turned off S3 BPA. So BPA stands for bucket public access. So now we have a more narrowed down scope of what exactly is happening. So having our bucket public access turned off is not a great thing. So your bucket right now is exposed to the world. So what we're gonna do is go to our S3 bucket over here. Okay, and we're gonna look at our bucket. We're gonna click on the bucket that has been misconfigured, which is the web static file. And then we're gonna look at permissions here. Okay. So as you can see, blocking all public access is currently turned off right now. So your bucket is actually exposed to public, which is a very undesirable kind of security state for your bucket. So we're gonna click on edit. We're going to enable blocking all public access. Save the changes. Confirm. So right now, there's a Lambda function running in the background that is checking for compliance states. As you can see, actually our bucket just changed from.
Your S3 web app static files bucket is now compliant.
Okay, so now it's compliant. So our bucket right now just changed from red status to green status, showing that now we have better security practices in place. So you can actually run this challenge across the board with all the different resources that we have. But I'm not going to spoil you or give you any hints and stuff. You got to come down and visit us at reInvent either this year, maybe even next year. So I hope you guys enjoyed the demo for today. And it's always important. Security is always day one. So I hope you guys enjoy it and have fun today.
Hi, my name is Christina Walb, and I am a Solutions Architect here at AWS, based out of Austin, Texas. And my project is a poker companion. It's called Poker Seer. And what we're doing is we are helping players get a better understanding of the math behind poker to help them make more informed decisions when playing. And then we can go over the architecture. So this is trained using Amazon SageMaker. We're using some computer vision, and then we are feeding the inferences to an Amazon Kinesis data stream. And from there, we are triggering an AWS Lambda function to perform a Monte Carlo simulation to give the odds of different types of hands that can come up through the rounds and the player's winning odds. And then finally, we're storing all of that data in DynamoDB and hosting this UI on AWS Amplify. So the demo will be, we'll have 2 players playing. We'll have one playing against the player with the companion and one playing with the companion. And they'll have their cards faced up to show the cameras what their cards are. And then we'll also be showing the community cards for the game. And as the game progresses and new cards are shown, the Monte Carlo situation will update with the odds of each of the different types of hands that they could possibly have. And with the winning odds, we'll be able to tell them what the next best move given the situation would be.
Hi, I'm Aastha. I'm a prototyping engineer from India, and I'm at reInvent 2023, and I'm presenting something called Bricks Maestro. This is the project that we have. The way it works is you can see all the Lego bricks over here. There are many of it. You can actually pick few of them, place it over here. There's a camera in front, and it's going to capture an image. Once the camera captures an image, it's going to detect the different bricks that you have, and that information is passed to an algorithm which is going to generate all the possible 3D structures that is possible with the bricks that you have chosen.